Welcome again. In this video I will solve question number 1.127 from the problems in general physics by IRODOV. The question says that a small body of mass m is located on a horizontal plane at the point O. The body acquires a horizontal velocity v0. Find the mean power developed by the friction force during the whole time of motion. For that we will have to calculate the total work done by friction force, and then we will have to divide that with the total time of motion. If the friction coefficient is k, mass is m, and initial velocity is v0. So there is a body of mass m which is moving with initial velocity v0, and let's say it is moving in the plus x direction. So there is no horizontal force working on the body except the friction force, which will act against the motion, so the body will start to decelerate. Let's try to calculate the friction force. This is normal force time coefficient of friction. As the friction force is working in the negative x direction, let's put a minus sign here. It's just a matter of convention. So the normal, let's try to solve for the normal force. Normal force is working in this direction, and weight is working in this direction. There is no other horizontal acceleration, vertical acceleration, so we can write weight minus normal force equals 0. So normal force is equal to weight, that is mass time g. So friction force will be equal to gk, and the deceleration due to friction force will be E equals minus zk. Now the mean power developed will be total work done by the friction force divided by total time of motion. As we know from the work energy theorem, work done by conservative force, which is equal to 0 here, and work done by non-conservative force, which is the friction force here, equals change in kinetic energy. So work done by conservative force is 0, work done by friction, the final velocity will be 0, and the initial velocity was 0 minus initial velocity was v0. So initial kinetic energy was minus half m v0 square. So work done by friction is equal to minus of half m v0 square. Now for calculating total time of motion, let's use the simple kinematics relation, that is final velocity equals initial velocity plus product of acceleration and the time. So final velocity is 0 here, initial velocity was v0, acceleration was zk, and t is the total time. So total time will be v0 by zk. So the work done by friction will be minus of half m v0 square divided by v0 by zk. So it will be equal to minus of half m gk v0. Now let's try to solve the second part of the equation. It says that the maximum instantaneous power developed by the friction force if the friction coefficient varies as k equals alpha times x, where alpha is a constant obviously and x is the distance from the point O. So instantaneous power is given as dot product of force and velocity, as we are working in one dimension, so we can simply write it as force times velocity. The force will be in this case minus of mg, it was mgk, but k varies as alpha times x. So we have to calculate the velocity, instantaneous velocity. So now writing this as force equals minus mg alpha x. Force is nothing but mass times acceleration, that is dv by dt minus mg alpha x m cancels out. So the variable in the left hand side are velocity and time, but in the right hand side there is x, so we will have to apply the chain rule. dx by dt minus z alpha x. Dx by dt is nothing but velocity dv. So we have the equation in terms of velocity and x only, there is no t, so we can now integrate it. So let's for initial velocity was v0, let's say we are integrating it to some final velocity v. So x is the initial position, that is obviously 0. Let's say at v x is equal to x. So after integrating it, v square minus v0 square minus z alpha x square. So final velocity v will be, so instantaneous power is given as minus mg alpha x times v. Now in order to calculate the maximum instantaneous power, we will have to differentiate equation with respect to x, as x is the only variable here, and equate it with 0. So now differentiating it, equate it with 0. Now solving this equation, we will get v0 square minus z x square equals z alpha, it was alpha x square. So x will be equal to v0 divided by 2g alpha root over. So maximum instantaneous power was minus mg alpha x v0 square minus g alpha x square at x equals v0 by 2g alpha. Now solving this, we will get minus of half m v0 square under root alpha z. So this is the final solution, this is the maximum instantaneous power. So thank you for watching, and subscribe to my channel for more solutions to the problems in general physics. Thank you.